We're looking at graphing logarithmic functions. We'll start with the one on the left here. It's a generic kind of logarithmic function, log base 3 of x, and work our way up to doing more complicated ones like the one on the right. Well, the first time I do a graph of any kind of function, I usually do it by plotting points, and that's what we'll do here, but this is the one and only time we're going to do that. From here on in, we're going to know what the shape of a generic logarithmic function looks like, and we'll be able to use that to graph ones like the one on the right that are variations on that theme, and we won't need to plot points again. So most of the time, I find 0 to be a pretty good place to start, so I'm doing log base 3 of 0. Except this time, log base 3 of 0 means what exponent do I have to put on 3 to make it come out to 0? 3 to what power gives me 0? Well, if it's a positive 3, and I put any power on there at all, positive, negative, doesn't matter, I'm going to get a positive number as a result, not 0. I can't turn positive 3 into 0 by using an exponent. You can't turn straw into gold either. So 0 won't work. I have to pick something else. Let's pick 1 instead. Let's see if we fare better with that one. Log base 3 of 1. Now I'm saying 3 to what power gives me 1? Well, anything to the 0 power is 1. 3 to the 0 power is 1. There's my first point, 1, 0. I could try f of 2, but then I'm saying 3 to what power gives me 2? I don't know that one. So I'm going to skip over 2 and go to 3 because I can do that one. So out of convenience, we'll pick x equals 3. Now I want log base 3 of 3. That's asking the question, 3 to what power gives me 3? Well, 3 to the first power is 3. There's my next point, 3, 1. Again, I'm going to run into the same problem with 4 and 5, etc. that I ran into with 3, which is we can't evaluate them easily. The next value that we can use easily with base of 3 is 9, which is the power of 3. Log base 3 of 9. Well, that means 3 to what power gives me 9? 3 squared is 9. Second power will do the job. We can't try negative values, but certainly there are values between 0 and 1 that we could use. Again, pick ones that are going to be painless to evaluate. I'm going to pick 1/3, because there's a 3 involved in there, and my log is base 3. Log base 3 of 1/3. Well, to get something in the denominator, I know that's going to require a negative exponent. 3 to the first power is 3, so exponent of -1 will do the job. Let's try one more. Again, picking a convenient one, I'm going to pick 1/9. Log base 3 of 1/9. Again, I can see I'm going to need a negative exponent because the 9 is in the denominator, and 3 squared is 9, so -2 will do it. That's a pretty good collection of points. Let's see what kind of picture we get by using those. My points, I have a point x is 1, y is 0. Did I not tell it to draw? X is 1, y is 0. There we go. Okay. Next one. X is 3, y is 1. So I'm going to have a point about there. Next point, when x is 9, 4, 5, 6, 7, 8, 9. Y is all the way up to 2, so I'm going to have a point about there. Now I have values between 0 and 1. We already said we can't use anything negative. I can't go down to the left at all, so there's going to be nothing to the left of the y-axis. I have a point at 1/3, -1. and a point really close to the y-axis, 1/9 and -2. If I connect the dots, we see that we're going to go up, but slowly out to the right. And on the left, I know I'm not going to cross over the y-axis. I'm going to go actually steeply down right next to the y-axis. Well, a line that my graph goes next to, but doesn't touch and doesn't cross, we have a name for that. This is a vertical asymptote. So exponential functions have horizontal asymptotes. Logarithmic functions have vertical asymptotes. The equation of a vertical line is x equals a value, because that's the y-axis, it's x equals 0. And since anything to the 0 power is 1, that very first point that we found, 1, 0, is going to be an important one to keep track of also. So we have a nicer version. There's the Desmos version of log base, that's actually log base 2 of x, but we can change it to base 3 easily enough. There we go. Oh, no, we don't. There, log base 3 of x, and that looks pretty much, we can see the vertical asymptote there. We can see the intercept 1, 0, and we can see the purple graph there going slowly up to the right. That's our overall shape of a logarithmic function. So let's try the next one that has variations on that theme. I see, first off, there's a +2 inside the parentheses with the x, which is going to cause the whole graph to move 2 to the left. Those changes that we talked about in the past, shifting, stretching, and reflecting, are the same idea no matter what the graph is. So +2 inside with the x is going to make the whole thing move 2 to the left. Next one, I have a negative on the outside. That's a reflection. Multiplying by -1 is a reflection. On the outside, we're going to reflect up to down vertically across the x-axis, however you like to think of that. And finally, we have a -3 on the outside, which is going to cause the whole thing to shift down, down, down by 3. We need to follow the point and the asymptote. Let's think about the asymptote. I know it's going to be vertical, so it has equation x equals something. If I take a vertical line and move it 2 to the left, that whole vertical line is going to move 2 to the left. So the new home for my asymptote, x equals -2 so far. If I reflect a vertical line vertically, the top of the vertical line goes down and the bottom of the vertical line goes up, and I end up with the same vertical line. So that doesn't do anything to it. If I take a vertical line and move it up and down, again, nothing happens. Same vertical line. So that left shift by 2 is the only thing that affects the vertical asymptote. Now we need to follow the point. The original point on the original generic graph is 1, 0. And we're going to take it through all of these transformations. First thing it does is move left 2. So now it's going to be, let's see, left 2 from 1 is -1. Then we're going to reflect it over the x-axis. Well, the y-coordinate is 0. If I reflect that over the x-axis, it's still 0, so nothing happens. That's a point still on the x-axis. And finally, I'm going to move the whole thing down 3. That's a y change. So the new home for my point, x doesn't change again, but y moves down 3. When we graph logarithmic functions, we want to draw the asymptote. We'll draw it as a dotted line. My asymptote is x equals -2. So I'm going to put a dotted line, hopefully, there it is, sort of, at x equals -2. There we go. My point is -1, -3, which is there. My original logarithmic function went slowly up to the right with a vertical asymptote going down to the left. I'm reflecting that, so everything up goes down, everything down goes up. Instead of going slowly up to the right, I'm going to go slowly down to the right. And instead of going sharply down along the vertical asymptote, I'm going to go sharply up along my vertical asymptote. This way. There's my graph. As always, we'll let Desmos fill us in how that should look. So we have y equals negative log base 2 of x plus 2 minus 3. There's our point. Well, it is. Even if it doesn't want to show us, there's our point at -1, -3, and we can see the vertical asymptote at x equals -2.